Hello, my amazing Algebra 1/2 students. This is Mrs. A, and I love math. We're working on lesson 12, and it's all about prime numbers and composite numbers. So we need to figure out, now, composite or composite, they both work. They're both the same word. So don't worry about that. Now, the number 6 is composed by multiplying 3 times 2 together. Okay, so since 6 is made up of, is a product of two numbers that are not 6 and 1, 6 is a composite number. Okay, composite product of other numbers besides itself and 1. So any number that has other factors would be composite. So here we've got prime whole numbers greater than 1 with no other factors besides the number in itself. Those would be prime numbers. So every number except for the number 1 is one or the other. It's either prime or it's not prime, and it's composite. But 1 is neither, okay? Because 1 does not fit the definition of prime. So let's look at the formal definition of prime, and then we're going to look at all of the prime numbers up to 40. Okay, so here are our prime. Here's our prime number definition. A prime number is a whole number greater than 1. So 1 is not a prime number, whose only whole number divisors are 1 and the number itself. Now, when you think about the number 1 does not fit into this definition because 1 is the number itself. So it does not really fit into the prime number definition. Neither is it composite. Therefore, we just say the number 1 is neither prime nor composite. And now, example 12.1 says, write the whole numbers 1 through 40 and circle the prime numbers. Do not circle 1 because 1 is not a prime number. I'm doing this in the book because they write ever so much more neatly than I do. Notice that they have then 1 through 20 on the top, 21 through 40 here. And now they're circling the numbers that are prime, which means they do not have any other factors. So let's look at these here for a minute. 1 is neither prime nor composite. 2 has no other factors besides itself and 1. 3 has no other factors besides 3 and 1. Neither does 5. Neither does 7. But notice any even number after 2, any even number will be composite because there's a 2 in there. We just did the divisibility rules, so if it's divisible by something, then it is not going to be prime. So 8 is divisible by 2, 9 is divisible by 3, 10 is divisible by 2 and 5. Okay, 12 is divisible by 2. 11, though, is a prime number. 13 is a prime number. There's nothing else that we can divide those numbers by except for 13 and 1, 11 and 1. Okay, 14 is even, so it is not prime. 15 has a 3 and a 5. 16 is even, 17 is prime. 18 is even, 19 is prime. 20 is even. Okay, 21 can be made up of 3 and 7 multiplied together. 22 is even. 23 is prime. 24 is even. 25 is a multiple of 5. 26 is even. 27 is a multiple of 3. 28 is even. 29 is prime. 30 is a multiple of 3, 10, lots of things, right? Number 31 is prime. 32 is even. 33 has a multiple of 3. 34 is even. 35 has a multiple of 5. 36 is even. 37 is prime. 38 is even. 39 is divisible by 13. And 40 is even. So that's just the numbers through 40. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 prime numbers up through 40. So now let's go on to product of primes. Finding products of primes is one of my favorite things to do. I think it's so much fun. Okay, 12 is pretty easy. We can see that 12 is 2 times 2 times 3. But let's think of a pattern that we can do this with. So instead of just drawing it out of our head, let's take 12 and let's divide it by the first prime number that we know goes into it. 2 goes into it because it's an even number. So if we divide by 2, 2 goes into 12 6 times. Okay, now notice I'm doing my division a little bit differently because this is going to be repeating the division until there's no more, there's no composite number left. Everything is prime numbers. Okay, so 6 is divisible also by 2. So I'm going to put the 2 there, and 6 divided by 2 is 3. So now 3 is a prime number. So I don't need to divide it by anything else. I have 2 times 2 times 3. All the numbers are prime, and there are no composite factors left. So 2 times 2 times 3 is the product of primes, and the product of primes is unique. You cannot get a different product of primes no matter how you do the division. Suppose we did the same thing, but instead of 12 and dividing by 2 first, so we got 2, 2, 3. Now I'm going to erase these, and we're going to do it again, but we're going to start differently. We're going to start with 3. 3 goes into 12 4 times, but we know 4 is 2 times 2. So we still got 2 times 2 times 3, even though we did it in an entirely different order. Okay, so let's practice this a little bit. Let's do a bigger number. Let's do 84. Well, as long as the number is even, put a 2 into it. Okay, 84 is even, so we're going to put in a 2. And I'm going to just make a little line here so we can see what we're doing here. Okay, 2 into 84 leaves 42. And 42 is still even. So let's do another 2 because we don't even have to think about it. Okay, 2 into 42 is 21. 21 is still made up of other numbers. Namely, there's a 3 in 21, and then that leaves us 7. So 84 is going to be a composite number that is made up of 2 times 2 times 3 times 7. Okay, so now suppose that we wanted to show that we're going to get the same thing even if we divide a different way. Okay, so remember we always put prime numbers in here. So let's start with 7. It's not quite as easy because I have to think about it a little bit more. 7 goes into 8 one time, and then there's a 14 left. So 7 into 14 goes 2. So 12 times 7 is 84. So now we're going to take the 12 and divide it by 3. And 3 is prime, and then we're left with 4. And then the 4 will be 2 times 2, which gives us our same factoring that we had before. 2 times 2 times 3 times 7. We call this prime factoring or product of primes. And when we express a number as the product of primes, there's a certain way that we always do it. We always start with the smaller digits and we move up. Okay, now we also will normally, pretty soon you will replace this 2 times 2 with a 2 squared. Because 2 times 2 is 2 squared. But right now they're letting you just write it this way. So let's do this one. And I can see that it is even. So I'm going to throw in a 2. Okay, so 2 goes into 12 6 times. With nothing left over, 2 goes into 6 3 times. And I'll drop my 0. Okay, now it is even, but I can see a 3 in there. So I'm going to pull out a 3. To me, that's easier. So 3 goes into 6 2 times, 3 goes into 3 1 time, and then I drop down the 0. And can you see a 3 in there? So put in another 3, and then I get a 70. And then I'm going to divide by a 7 and get a 10, and divide by a 2 and get a 5. And I have a whole bunch of factors, don't I? So 1,260. Now remember, we always start with the least number. So we're going to start with 2 times 2 times 3 times 3 times 5 times 7. Okay, and this one is also in your book, and they have those factors in your book. And guess what? If you did it in a different order, suppose right there you divided by 3 instead of 2, you would get different numbers here, but you would get the same factors out here, wouldn't you? Okay, so now let's do your practice. Okay, so our first practice problem is to prime factor or find the product of primes of 120. So I've already written this with my little box here, so I'm going to go ahead and divide by 2. And when I divide by 2, I'm going to get a 60. And then I put my little box again. And remember, this out here always has to be a prime number. So I could use 2 or 3. So 3 goes into 60 20 times. And then 20, we'll go ahead and use a 2 again. 2 into 20 is 10. And we know 10 is a 2 times a 5. So when I go to write down, I would say 120 is equal to, all right, I've got 1, 2, 3 2's. 2 times 2 times 2. And then I have a 3 and a 5 times 3 times 5. And it doesn't matter what I start out with. I could have started here with a 3 instead of a 2. I would have gotten the same answer. Here's the next practice problem, but this one I want you to do by yourself before I do it with you. Pause your video. Okay, so hopefully you did that. I'm going to go ahead and just do this by 2. Divide by 2. And 2 goes into 6 3 times evenly. 2 goes into 4 2 times evenly. And then I just bring down my 0. 2 goes into 0 0 times. So I have 320. And I'm going to divide that by 2 again. And remember, 32 divided by 2 is just 16. I don't have to think about that very much. Okay, so I get 160. I'm going to divide that by 2. And I'm going to get an 80. And I'm going to divide the 80 by 2. And I'm going to get a 40. And then I'm going to divide the 40 by 2. And I'm going to get a 20. And I divide the 20 by 2. And I'm going to get a 10. And I divide the 10 by 2. And I get a 5. That is a lot of 2's. Okay, so 1, 2, 3, 4, 5, 6, 7 2's, and then a 5. So because I have so little board space, I'm going to use an exponent. So we had 7 2's, so we could say that's 2 to the 7th times 5. And you will learn that notation very soon. Okay, and then we could say that is equal to 640. Or 640 is equal to 2 to the 7th times 5. There's your board. And this is our last practice. So, pause your video. Hopefully you already found the answer to this one. So let's start out by dividing by 2. Okay, so 2 goes into 2 evenly one time. And then 5 divides by 2, but not evenly. So I'm going to put a 2. And then I'm going to take the 1 that's left over and tack it onto the 2 here to make it 12. So 2 into 12 is 6. And then 2 into 0 is 0. So I divided that one by 2. And it's still divisible by 2, but let's shake it up a little bit. It's divisible by 3 also. 3 goes into 12 4 times, and 3 goes into 6 2 times. And I bring down my 0. So now I'll use a 2 again. And I get a 2, 1, 0. And now I'm going to use a 3 and get a 70. And use a 7 and get a 10. And divide by 2 and get a 5. So when I look at all of those factors, 2, 2, 2. So 3 2's. So because of my space, I'm going to write, instead of 2 times 2 times 2, I'm going to write 2 to the 3rd power, because that means the same thing, times 3. I've got 2 3's, so I'll say 3 squared. Notice that I'm going from smallest to largest. And then I got 3 squared, and then I have a 5 and a 7 times 5 times 7. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we have it. Hope you enjoyed lesson 12, and I hope you have fun doing your homework. This is Mrs. A, and may God bless your day.